I am finally getting around to this post from P911 or 911, as the case may be. I apologize for taking so long to get to your post, but uh, there you go. Anyway, here we are. P911 writes, pitch feels close to perfect. D term seems to be oscillating on gyro traces, and especially at 107, we're going to look at this roll, which is oscillating after the flip. Um, you are using gyrosync, and if you're using gyrosync, let's see, if you're using gyrosync, then you want to just set your loop time to 0 and let the firmware figure out what to do, is my understanding. And just to expound on that a little bit, this is the current understanding, as Boris has expressed and as I understand it, and I've done a little bit of research on my own copter, nowhere near as much research as I'm sure Boris has done, and have come to agree with him. Not that he really needs that, but I do agree. Uh, my results have supported his. And what that is you want to run gyro LPF equals 188. The reason for that is that forces the gyro sampling rate to 1 kilohertz. At gyro LPF equals 256, the gyro sampling rate is 8 kilohertz, and that is too fast for us to keep up with the loop time. If you have an F4 board, you can run 125 millisecond loop time, and then you can run at 8 kilohertz. But the goal is that you want to be processing every single gyro sample. So if the gyro is running at 8 kilohertz, you need to run at 8 kilohertz. Anytime you are running at less than the sampling rate, you do a thing called downsampling, and the effect is a thing called aliasing. And the effect of aliasing is that high frequency signals get copied down at lower frequencies. So if you have a signal at 250 hertz, then if you downsample, you can get a copy of that signal down at half the frequency or whatever. So that's aliasing, and you don't want aliasing because what you really want to avoid is aliasing of the prop frequency down into the frequencies below, say, 50 to 20 hertz. The reason is that the majority of the frequencies that you care about, in terms of good flight, in terms of not having oscillations and wobbles, etc., the majority of that data is in the sub, say, 50 to 20 hertz range. And so if you have some 125 hertz noise that is being aliased down, well, 125 is a bad choice. No, it might be an okay choice. I don't know. That doesn't matter. If you have some 125 hertz noise that is being aliased down into that frequency band, it's making noise in the place where you need the absolute cleanest signal to be there so that your copter can be responding to real external conditions, not a phantom signal that doesn't really exist. Okay, so you want to be sampling at exactly your gyro. You want to be running the loop at exactly your gyro sampling frequency, which for most people is going to be gyro LPF equals 188 and loop time 1000. Okay, if you can't run loop time 1000, the next best thing, and you'll see Betaflight do this automatically. If you're on an F1 board and you haven't disabled your accelerometer, it'll go to 2000. The next best thing is to have every other sample dropped. So 2 to 1 undersampling, if you will. And that there's still some aliasing, but that has the effect of minimizing the aliasing. So why not run lower gyro LPFs? Gyro LPF equals 96 or 42. And the reason is that the lower the gyro cutoff, the more latency there is, and it's better to get that filtering with gyro cut hertz, which is a soft filter, than it is to get that filtering with gyro LPF. So as Boris once said, if you could run gyro LPF equals 256 at 1 kilohertz, that would be the best. Okay, so enough about gyro LPF and loop time. But everybody out there, if you're running your loop time at 1200, at 1800, 1600, stop. You want to even if you're not running Betaflight, you still want to be running at a multiple, either 1,000, 2,000, a multiple of, or even 3,000, you know? But there's no reason to do 3,000 since everybody, even with an F1 board, can do 2,000, even if you're running soft serial and LED strip and all that nonsense. So yeah, even if you're not running Betaflight, set your loop time, set your gyro LPF to 42, and set your loop time to 2,000. Lower loop times create a bunch of noise at the lower frequencies due to aliasing, and that is probably hurting you more than the filtering is helping you, or reduction in latency or reduction in loop time, whatever. But if you're not running true gyro sync, you're still getting some aliasing because the gyro doesn't run at exactly 1 kilohertz, exactly 1,000 microseconds per loop, per sample. Sometimes it's, if you're running gyrosync and you look at your loop time, you'll see it goes down to, 940 maybe, and it's up to 1080. I don't know what the range is, but so it's still better to have yourself close to aligned. But unless you're actually running Betaflight with the real sync gyro to loop, you're still going to get some aliasing. Okay, enough about that. Let's go ahead and take a look at your stuff. Gyro cut 60, P term cut 40, D term cut 15. Nothing wrong with that. Gyro LPF 188. Nothing wrong with that. We'll have a look next at your dump. PID controller 2, Lux float, pitch P. Oh no, where's your? There we go. Oh, I was about to say, whoa, that's way too high. No, pitch PF. 0.9, roll 0.6, 38 and 55, 25 and 35. I think your D values are probably a little conservative, but not radically so. But everything else looks pretty normal. Your roll P is a little lower than I normally would expect, but I've said already in another video that I have a feeling that the effect of Betaflight and soft filters and all this other stuff is adjusting the normal range of PIDs that I expect to see. So this seems pretty normal for somebody who's running Betaflight. So it all looks fine. You commented that you're having some problems with yaw, I think. Is that yours? No, I guess that's somebody else's. Your yaw I is surprisingly high. I'm really surprised if it turns out to be the value that makes it fly the best. It's 100 basically, right? I'm really surprised if that turns out to be the value that makes it fly the best. I think that's probably making problems for you. If you love how it flies and you have absolutely no complaints, then keep it the way it is. But I'm surprised if that's the right value. So then what might a right value be? I don't know. That's really kind of mean of me to say that. I'm not sure, but I feel like 100. I've never had to turn yaw I up that high, and I've had yaw I, like, I don't even know what my yaw I is. Hold on, let me pause this video a second. I checked my last config dump. My yaw I gain is at 25. Now, granted, I'm not running Betaflight, and I'm not running Lux float either, but my experience has been that I gains are less sensitive to different P. They're more universal to the power system and the frame, and less sensitive to things like differences in the PID controller. So if I were to say a range of between, say, 20 and 50 is like normal for yaw I. I think whatever the normal range is, maybe it's 25 to 40, maybe it's 20 to 60, but I feel like 100 is probably way out of it. So let's go ahead then, and we will look at the log. Just for the sake of posterity, let's have a look at your gyros. We'll zoom out. Okay, they look great. That's enough about that. I said I was going to stop looking at every single person's gyros. What else have we got? Let's take a look at 107 before I run myself off the clock. Roll P starts oscillating after a flip. So we will look at pitch and roll. PID, and we will go to 107. So, where's the flip? Here we go. So, we're flipping forward. The P term goes positive as the stick goes up, pushing the copter into the flip. The gyro goes up, and now your flip is happening. We've had some people looking at I term, and I want to point out here, they've had a couple examples where people have had their I gain too high and the I term is really responsive. Look how long it takes the I term to sort of change directions. I term is, you can think of the I term like the Titanic, right? It's this great big ship. It shouldn't just swerve when it sees an iceberg, right? It just shouldn't be able to. If your I term is swerving around, the people on the decks are getting tossed about. Or something. I don't know. It's a bad analogy. But look at the I term here. The I term helps push into the flip. So that means, by the way, with the I term pushing into the move, that means that the P gain is not high enough to prevent error. If the I term is agreeing with the P term in terms of being above or below the axis, they're on the same side of the axis, that means that the P term could go higher and the I term would go down until you get to the point where you would start getting oscillations. But at this point, the P term is not pushing hard enough, and the I term is picking up the error that's left behind. Okay, that doesn't mean that your P gain is too low. It doesn't mean that your I gain is too high, but it just means that if you had to pick between too high and too low, the P gain is a little bit on the low side. If we see that the I term is opposing the P gain, so P goes up, or the P term, so P goes up and I goes down, then we know that P is on the high side of normal. And there's usually not going to be some perfect p-value where I just stays at 0 the whole time. If that were the case, we wouldn't need the I term at all. So the I term is there to do its job, right? So the fact that it's doing its job doesn't mean anything is wrong. But we know which side of high or low we're on by which direction the I term goes relative to the P term. Okay, notice that the I term, I was talking about the Titanic and the I term changing directions. Notice that the I term, it slowly moves down and goes the other direction. So as we get through the middle of the flip, the accumulated error goes to 0. And notice that by the middle of the flip, both P and I are very close to 0, which means we have almost exactly achieved the angular rate that we wanted to achieve based on the stick position. Okay, and that's ideal. That's really ideal. A flip gives we see a lot of instability. The P term goes up and down and so forth as the error pushes into and then overshoots a little bit and going too fast, and so then it slows down, and then but as the flip continues to occur, there's plenty of time for it to figure out where it needs to be and get there. And the fact that it gets there and that in the middle we see the I and the D, the I and the P close to 0, that is a sign that you're probably about where you need to be in terms of tuning. Also notice that the I term, it doesn't go whoop and then jump down again, but it crests and then it falls off and it gets there and then it changes direction this way and now it's going over here. That's what you want. The I term should not be twitching about spastically. That's the D term's job. It's like crazy chihuahua jumping around. The I term is a big old basset hound and it's just loping along and the chihuahua is running circles around it, right? Okay, there's another silly analogy for you. So this flip looks pretty good. At the end of the flip, why does the roll get destabilized? And the answer, there's no mystery here. The answer is just that anytime motors are spinning like crazy, there's going to be a little bit of destabilization on all the axes. So this is completely normal. In fact, the fact that you're so stable through the middle of the loop is actually really good. You know, a lot of times during a flip, I will see more destabilization. The P term will be more active. But here the P term is really pretty quiet. So I don't think anything's wrong here. It's just you brought your stick to 0 and the copter had to stop spinning, and I'm going to go to part 2 of this video. You get a part 2, P911, because I took so long to respond.